Python includes special syntax that allows us to easily iterate through the items in a list collection. The syntax for this type of repetition structure is the reserved word for. That's what tells Python that we would like to repeat this and that we're going to perform an iteration process over a loop. So we say for, then we give the individual item that we'd like to process a name. And at this point in our program, that doesn't have to already exist. Our list has to exist at this point, but we don't need to have previously define a identifier that refers to just one item. So this can be a new identifier in your program, something that you're just going to use in the context of this loop to reference one item. Then we use the reserved word in, and then finally include the identifier of the whole list. That's the identifier, the name that refers to our entire list collection. Then at the end of the instruction, we put a colon, and that's what tells Python the steps that follow and are indented below here are things that you should do as part of the algorithm to process this individual item that exists within this list collection. And your algorithm can have as many steps as you'd like. So it could have one step like in our extra credit example, or it could have lots of steps. This example shows what it would look like if there was 3 different steps. We'd have step number 1, step 2, step 3, each of them on its own individual line, and all of them are indented underneath this for instruction. If your algorithm has any actions that you'd like to complete after the repetitive process finishes, you can include those as well. They would be below your list iteration steps, and they would not be indented. They're going to be at the same indentation level as your original for reserved word. So under the F, you should have the instructions that don't get repeated lined up under there. So again, this particular syntax is going to tell Python that we want to process this list, the one indicated by our identifier. As we're processing it, we're going to call the individual items, whatever identifier we put over here, and that we're going to repeatedly carry out these 3 instructions on each of those list items. Then after we finish repeating those actions for each item, we're going to take this one final action to complete our program. Python already knows how to carry out these instructions effectively. It will repeatedly apply our algorithm to each item in the collection until we run out of items. When we run out of items, we say that the iteration process has terminated, which just means it ended. Here are a few things to keep in mind when we're writing repetition processes. First, the steps that are being applied have to be identical for every item in the collection. If you have steps and they're not exactly identical, we'll learn how to do that later on in the semester, but for right now, we only know how to apply the same steps to each item in the collection. Don't forget to indent all the steps that have to be applied to each item. If you don't indent consistently, Python will choose not to associate some of your statements with your repetition instructions. If there's any steps that should occur after the loop iteration is complete and the loop terminates, then don't indent those steps. The indentation is what tells Python which items to group with the for command and which items are not part of the repetition. Let's try out the repetition structure using our extra credit example. Suppose that we have 10 items that are stored in our quiz score list representing 10 different student scores. So this first statement here, that's just initializing the value of our list. It's putting the value 765489243 into our 10 item list collection. And now, instead of writing out those 10 statements to add the to value to each individual item, we're going to be able to replace those 10 instructions with these 2 instructions. We'll be able to say for score in quiz score list. That means for each item in the quiz score list, call that individual item's score, and then apply the algorithm that's down here after the colon to each of those individual scores. And in our algorithm, we know we wanted to print the value of the score and add 2 to it. So in here, we're saying add 2 to the score, and then print it out. When we execute this, the output of our program is going to be identical to the program that we wrote earlier in today's lecture. It's going to print out the 10 different quiz score values. Note that when we're printing out the values using this format, each item prints on its own individual line. And that's different than what we've seen in the past with Python. Let's pull up a Python window so that we can see the difference and how that operates. All right. So our quiz score list has these values in it. Oops. 7, 6, 5, 4, 8, 9, 2, 4, 3, 8. And remember at the beginning of the lecture today, we said we could write a program that prints each of these individual values out and adds a value 2 to it. I'm going to copy and paste that a couple different times. Oops. I'm going to copy and paste that a couple different times. Awesome. Again, this isn't too tedious if we only have 10 items in the collection, but you can imagine how annoying it would be if you had hundreds of items in the collection. So if we run that, see that the items print, and each of the items is printing on its own individual line. That's different than when we just say print quiz score list and print the whole list at once. Remember, when we do that, Python's going to print it all on a single line with those square brackets between them, which we said is like just fine if we want to just test out our program and see what's happening. But if we were trying to communicate something to an end user, this is not the most user-friendly way of communicating the contents of the list, because there's no labels and it has these weird square brackets. It just doesn't look very pretty. All right, so now let's edit our program so that we include the for loop. So we said for score in quiz score list. And notice that after I press enter after that colon, Python automatically indents over here. That's because it knows that I'm getting ready to include instructions that go along with this repetition statement. So it automatically indents whenever you end the previous statement with a colon. And we wanted to print out score plus 2. And again, we're getting exactly the same answer, exactly the same output this time. But we saved ourselves a whole lot of typing. It was much, much, much easier to type in these 2 commands than it was to type in the 10 commands to process the individual list items. And you can see that that would just intensify and be even more efficient if we have a really large list that had hundreds or thousands of items in it. This particular syntax is also a great way of printing out information about the items in a list if we want to do it in a customized way, not all in a single horizontal statement. So if we wanted to say something like the updated value is we could do that. And again, it's a way of displaying all the information in our list where each item is on its own special line, and we could include a customized label for each of the items. That would make our output more readable and more understandable to an end user.